r equals the cosine of theta. And that equation, hopefully it's obvious, that equation is in polar coordinates. How could we convert it to rectangular coordinates? Well, it's not always easy. There's not always an elegant way to do it. You just have to make the conversion equations fit, maybe adjust them a little bit. But in this case, there is a neat trick that you might have learned. So look at the conversion equations. Again, we've got x equals r cosine theta. I don't think that's going to help too much. Tangent theta is equal to y over x. And we have r squared equals x squared plus y squared. Oh, maybe one of those will help. X equals r cosine theta, y equals r sine theta. Okay, so what are we given here? Oh, we have on the right-hand side cosine theta. It would be nice to have what in terms of those equations above? It would be nice to have r cosine theta. And wouldn't it also be nice to have r squared? So we're given cosine of theta, but here, I'm trying to get you guys to look.
Can you plug in what r equals into the bottom equation?
You could, but that might be doing it the hard way. So we have cosine. Look at what you have. You have cosine theta. It would be nice to have r. It would be nice to have r times cosine of theta. You have r. It would be nice to have r squared. Is there a way to get both all in one? That's exactly right. So just rewriting the given equation, we have r cosine of theta. Now I'm not squaring both sides. I'm multiplying both sides by r. That's the trick. And you're going to see this trick many, many times. Not just in this class, but in Calc 2. Calc 2 will be the next time you see polar coordinates. So that gives us a very nice form to work with. R squared, meant to switch to green. R squared equals r cosine theta. It gives us a nice form to work with because we know what r squared is. We've got a nice thing to set that equal to. We know what r cosine theta is. We've got something nice to set it equal to. So what is r squared again?
X squared plus y squared.
So I'm just going to replace r squared with x squared plus y squared. What is r cosine theta?
X.
There it is. Now, we can go a little further, but that is the equation in rectangular coordinates. But we just got done talking about these kinds of equations. Any guesses on what this graph's to be? An ellipse is a good guess, but it might be a special kind of ellipse. A circle. Well, how could we be sure? What can we do? Graph it, but before we graph it, what do we need to do? We have to put it in standard form. So here's a good review of 5.2 stuff. What would we do first to put it in standard form?
Isolate the y.
Good, and get the powers of x together, right? So I'm going to subtract x from both sides, you guys. X squared minus x plus y squared, and then that leaves me for the time being with 0 on the right-hand side if I subtract x from both sides. And so then what's the trick here? Maybe leave a little more space. Well, actually, I've got a 1 in front of the x squared. That's all I need. So what do I have? X squared minus 1x if you want to put the coefficient in there. And just go ahead and complete the square on x squared minus x. What do you have to do first?
Take half of the, oh yeah,
Well, no, the y squared's good. The y squared's good. That's right. But what do you do to get the 1 over 4?
half the 1.
You take half the coefficient of the x, which is, yeah, well, no. Negative 1 is the coefficient of x, right? So what's 1/2 of negative 1? Just multiply by negative 1 by 1/2. And you get negative 1/2. Notice I wrote it down there. And then the process, remember, to complete the square on x squared minus x then is to square that number and add it in there. So what do you get when you square negative 1/2? 1/4. So you add in 1/4, but you have to balance it out, right? So add 1/4 to both sides. And then what does x squared minus x plus 1/4 factor to be?
X minus 1/2.
Quantity.
Squared.
Yeah, quantity squared. And then we still have the plus y squared equals 1/4. So this is the equation in standard form. And okay, it's not the standard form of the ellipse, is it? It's the standard form of what? A circle. If you wanted to, you could divide both sides by 1/4 and get 1 on the right side, and then that would be the standard form of the ellipse, but there's no reason to. Because we know the standard form of a circle looks like this. It looks like, well, x, if it has a center other than the origin, x minus h quantity squared plus y minus k quantity squared equals r squared, right? In this case, what's h and k?
1/2 and 0.
What's h and k? H and k, oh, I'm sorry, you're right. I was thinking something else. You are right, sir. So the center of this thing is, capital C for center, 1/2, 0. H and k are 1/2 and 0. Does everybody see that? We should probably identify the fact that this is a circle, so maybe I should have done that first. So this is a circle. It is an ellipse, but if it's a circle, state that. Don't state that it's an ellipse. C for center, capital C for center of 1/2. What's the radius?
1/2.
Yeah, does everybody see why the radius is 1/2? Because on the right side, it's actually r squared, right? So if you take the square root of what's on the right side here, you get a 1/2. Square root of 1/4 is a 1/2. So I like to ask this question on the test, because it not only tests you on converting between polar coordinates and rectangular, it tests you on whether or not you can complete the square and identify the conic section. So it's kind of an all-in-one problem, so I like this problem. If I ask it on the test, it won't be exactly the same, but it'd be similar.